In the last session, we discussed what is Jenkins, how to set up Jenkins in the Linux machine, and how to install Docker in the Jenkins, how to create freestyle project in the Jenkins, and how to create pipeline in the Jenkins. In the Jenkins, we can create the jobs in two ways. One is by using freestyle project. That means with the help of GUI, we can create the job, or else we can go for pipeline. When to go for freestyle project, when to go for pipeline project. When to go for freestyle project and when to go for a pipeline project. If you are using a small project deployment, your project deployment process is very simple, just to take the code and deploy, then you can go for freestyle project. If your project is having complex build and deployment process, then we need to go for pipeline. So this is called CI/CD pipeline, nothing but continuous integration and continuous deployment. So in the CI/CD pipeline, multiple stages will be available. First stage, it is used to clone the Git repository. So it is going to download the code from the GitHub based on the given URL. Then second stage, I want to perform Maven build on the project. By using MVN clean package, you can perform the Maven build. Once we perform Maven build, it will compile our project and it will package our project as a jar file or war file. And to execute our project, we are going to use Docker. So Docker is a containerization platform. By using Docker, we can build Docker image. So using this command, we can build Docker image for the project. So where is the Docker file to build the Docker image? For our application to build the Docker image, Docker file will be available in the Git repository itself. So using this command, we will build Docker image for the project. Once the image is created, we can run that Docker image. So we are going to run Docker image in the detached mode. So when you run the Docker image, Docker container will be created. That container we need to map to the host machine. Container port we are going to map to host port by using -p option. Whatever the image we have created, that image name we are giving so that it will run the container. Suppose if you want to deploy your application on the Kubernetes cluster, instead of using this command, what we are going to use, instead of using this command, we are going to write sh kubectl apply -f our deployment manifest YML. So deployment YML file will be available. Now we can comment this and you can run this command. Then our container will be created using Kubernetes cluster. Pod will be created. In the deployment YML, deployment specification will be available and service specification also will be available. Good. So with this, we understood what is Docker and how to deploy our project by using Docker. So in the Docker, we can schedule the job schedule we can do. First one, there is an option called build now option is available. What is the meaning of build now? Yes, build now option is used to run the job immediately. Whenever you want to run the job, then immediately you can run that job. Then second option, there is a concept called run build periodically. There is a concept called build periodically. What is the meaning of build periodically? I want to run the job based on the given schedule. Every minute, every 30 minutes, every 1 hour, I want to run the job. When you go for build periodically, it won't check whether code is modified or not. Automatically, based on the given schedule, it will be executing the job. And there is another option called poll SCM option is available. What is the meaning of poll SCM? It will be checking the Git repository. If code is modified, then only it will run the job. If code is not modified, it will not run that job. Right. So these are the three options. Guys, in the real time, what will happen? What is the process in the project? Real time process. real-time process. In the real time, what we need to do is the Jenkins jobs creation is the duty of the DevOps engineers, right? So as a developer, what we need to do when we are starting any project, it can be a monolith project or it can be a microservices project, right? When we are running the project, dev team should send dev team will create JIRA ticket for pipeline creation. Whenever we are doing that sprint planning or when we are creating backlog tickets, right? In the sprint, we will create one ticket for pipeline creation. So for example, assume that the ticket is created AR ticket number some 342. So we are working on AR module. So AR is one microservice. It is one project. I want to deploy that AR project, right? To deploy that AR project, we are going to create one JIRA ticket for the pipeline creation, ticket number 342. Now, dev team member will assign that, will take that ticket and will assign to his name. For example, today I want to work on some story. So I'm going to check which stories are pending in the JIRA dashboard. I found that there is a story called 342. There is a story whose number is 342. That story is related to Jenkins pipeline creation. Now, I have assigned that story to my name. I'm going to work on that story. Then what I need to do is send email request, send request to DevOps team to create Jenkins pipeline. To create Jenkins pipeline for non-prod environments. For non-prod environments, dev job, QA, SIT job, UAT job. Like this, we are having some non-production environments as well as production environment. To create the job in the SIT, UAT, and the dev, we are going to send request to DevOps team to create Jenkins pipeline for non-prod environments, right? So we will write one email. Hi DevOps team, I'm working on the story number 342. It is related to Jenkins pipeline. Please create the pipeline for the Jenkins pipeline for AR module for all the three environments. Below is the Git repository URL for that. So we need to give the Git repository URL. Using that Git repository URL, they will create Jenkins pipeline for non-prod environments. Here, DevOps team will create pipelines. DevOps team will create Jenkins pipelines and will give reply to our email as confirmation. We send an email for them to create the pipeline. DevOps team will work on that pipeline creation. Then DevOps team will work on the pipeline creation. Once the pipeline is created, they will respond to our email. Yes, I have completed pipeline creation. Please confirm. Now, as a developer, I am working on this story. For example, I have taken this story. Now, they have created the pipeline. They responded to that email which I have sent. Now, what I need to do is developer will test pipeline. Developer will test pipeline functionality by deploying sample application. We have created a project in the GitHub. A dummy project will be available initially. Just hello world or welcome project will be available. Developer will test pipeline functionality by deploying sample application. If the pipeline is working, excellent, no problem, task is completed. If the pipeline is not working, then we need to give reply back to the email. I have executed the pipeline, but it is not working. There is some issue. So if it is working fine, then good. If build and deployment successful, if a build and deployment is a success, then developer will close JRTP ticket. If a build and deployment is success through that pipeline, then developer will close JRTP ticket. If build and deployment is failed, if a build and deployment is failed, developer should find root cause. Developer should find root cause. Why it is failing? Is it because of code problem? Is it because of pipeline problem? For example, when we execute the pipeline, console output will be available. When I see, it is saying that Maven not found. That means in the Jenkins machine, Maven software is not installed. Is it our problem? It is DevOps engineer problem. It is DevOps engineer problem because they need to install the softwares which are required to run our pipeline. Suppose it is saying that compilation failed. In the project code, semicolon is missed, compilation is failed. If a compilation is failed, that is developer problem. We need to correct that code and we need to commit the code again to the GitHub. We need to rerun the job, right? So if the mistake is from the developer side, if a failure is code side, then developer will fix. If a mistake is in pipeline, then DevOps team will fix it. So that coordination is required. That communication will happen through email. If the build is failed, we will check the root cause. If it is a code problem, we will change that code. We will commit that code to the GitHub and we are going to rerun our Jenkins job. Suppose if the problem is due to that Maven is not installed or Docker is not installed or Kubernetes is not installed, that is pipeline problem. DevOps engineer should fix that problem. How DevOps people will know that where is the problem? We are running the job. We will take the screenshot of that console output. We will send the reply back to the email. I have executed the pipeline. It is failing. This is the log of the job execution. By looking at the log, we will understand, is it developer problem? Is it pipeline problem? Is it code problem? Is it pipeline problem? If it is code problem, we have to fix. If it is pipeline problem, then DevOps team will fix it. Once the pipeline is working successfully, once pipeline is a success, is already done, right? If a build and deployment is success, then developer will close the JIRA ticket. If a build and deployment is failed, developer should find root cause of the failure. If a failure is code side, then developer should fix it. If failure is in pipeline, then DevOps team should fix it. So this is the process that we are going to follow in the real time. As a developer, we are not going to create the pipelines. We will send requests to the DevOps team to create the pipeline for non-prod environments, right? DevOps team will create pipeline and will give reply to our email as confirmation pipeline is created. Once pipeline is created, we need to test it. We need to log in into Jenkins machine, go to the job, click on build now. So here, when you click on the build now, is the job is working as expected or not? If the job is working as expected, then good. We are going to close the JIRA ticket. If the job is not working, we need to find the root cause of the failure. Why that job is not working? So is it code side problem? Is it pipeline side problem? If it is code side problem, developer should fix. If it is pipeline problem, DevOps team should fix it. Could you please read these points? Yeah, everybody will have access for Jenkins. We will have our own user account. They will create users in the Jenkins. I will have my credentials. You will have your credentials. They will write all the stages. You no need to do that. When you are sending the email, you will send the Git repository URL to them. Send request to DevOps team to create Jenkins pipeline for non-prod environments with Git repository URL. That means dummy project Git repository will be created. sample application we will create and we will push that code. Yes, right. Dummy project, just one class will be available. Correct. No. If it is success, you don't need to send the email. You will just commit your code to Git. You will run the same pipeline. Why you need to send to them? Yes, man. You already have a Git repository. You have a project structure. Sample project will be available. That means just your AR project will be available. Your controllers, services, nothing will be available. Just dummy project with the start class. Okay, that will be packaged as a jar file. It will be deployed. You can create dummy method, hello world method. If it is working, later you can commit your code to the same repository. Good. Read these points, guys. How we are going to work with Jenkins in the real time. Every team member will have the access for Jenkins login. Okay. Every team member, developer, tester, DevOps team. Every team member will have Jenkins access. That means user account will be created. User account will be created. DevOps team will create user account for all the team members. You will have the credentials. With your credentials, you will log in into the Jenkins. Then you can see what are the jobs available. You can run that job. Read the points. As part of sprint planning only, we are going to create the JIRA ticket for the deployment process, build and deployment. Huh? Developer will test pipeline. That means you just click on build now. You will run the job. Whether job is executing, your project is deploying or not, you will test it. By deploying, instead of sample, deploying application. That's it. Whatever the project you created, we will have the Git repository. We will run the job and it will be deployed. Is that project deployed or not? That we will test it. This total process is done at the time of project release. No, this total process will be done at the time of project startup only, not at the time of end of the project, at the time of start of the project only. End of the project, that is production deployment. Online for the production deployment, separate team will be available. That is called release team. Okay. Correct. In the interview, they will ask a question on this process. When you are attending experienced interviews, they will ask this: how your project will be deployed? Okay, you need to explain this complete process. So we will create a JIRA ticket for pipeline creation, and we are going to send a request for DevOps team with the JIRA number, with the JIRA ticket ID to create the pipeline. Once the pipeline is created, one of our development team member who is working on the story will run that job and will see job is executing successfully or not. If it is executing, then we will close the ticket. We will run the same job again and again to do the deployments on daily basis. If the job is not executing, we will see the console output. What is the root cause of the problem? If the problem is from code side, then we will fix that problem. We will rerun the job. If the problem is in the pipeline, we will send to the DevOps team. They will work on that problem. They will fix it. Then we will re-execute the same job to make sure the job is executing successfully. Right. Yes, sir. Yesterday I did not prepare that. Today I will make it. Sir, in the startup companies, separate teams are available or not? It depends. In some companies, teams will nowadays in every project, DevOps team will be available. If DevOps team is not there, then developers only should do all these things. Developers only should create the pipeline. Developers only should execute the pipeline to check whether that code is deployed or not. In my company, there are two types of environments available, right? Non-prod environments are available. Non-prod environments, nothing but here prod environment, nothing but it is live environment. Non-prod environment means dev available, SIT, UAT is available, right? Pilot is also available. So these environments in my team, for non-prod environments, DevOps team is not there. Developers only should perform activities on the non-prod, because even if we do something wrong in the non-prod, there is no loss for the client, because non-prod environments, nothing but those are internal environments. Developers will use, testers will use, clients will use. If something goes wrong in the non-prod, there is no loss, there is no damage, because if some mistake happen, we can correct it again, right? That's why in our team, developers only will work on pipeline creation for non-prod environment. But production environment, we have a separated DevOps team. Why? Because if we do some mistake in the production, application will be affected in the live environment, client business will be affected. So here for non-prod environments, dev team will handle. Dev team will handle non-prod environments. Production environment, DevOps team will handle. Right? Dev team will handle non-prod environments. Production environment will be handled by DevOps team. So when for production deployment, release call will be available. For prod deployment, release call will be available. What is the meaning of release call? A meeting. Suppose, for example, this Friday we have production deployment. They will schedule a meeting. How I am scheduling Zoom meeting for the online class? Similarly, they will schedule Teams meeting for the release call. So this Friday evening 6 p.m. we have production deployment. At 6 o'clock release call will start. In that release call, dev team will be available, testing team will be available, DevOps team will be available, managers will be available, Scrum Master will be available. Everybody in the project will be there in the release call. In that release call, DevOps team members will do the production deployment. When they are doing the production deployment, they will explain each and every step. First step, we are going to open the checklist. So for the production deployment, checklist will be available. Step 1. So go to the pipeline, run the pipeline and see, is it working or not? Take the code, code is coming or not? Do the map and build is happening or not? Create the Docker image created or not? Docker image, push to the Docker hub, pushed or not? Deploy to the Kubernetes cluster, check the pods created or not? Okay, then check the status of the pods, check the logs of the pod, send the request for the application, see application is working or not, see the logs of the application, logs are printing or not. So all these checklist we are going to follow. DevOps team will do the prod deployment. that prod deployment release call will go 2 to 3 hours of time. 2 to 3 hours meeting will be available. In that meeting, they will share the screen and they will be doing the production deployment. Step by step, they will explain what they are doing. Okay. So at that time, we will also observe how the production deployment is happening in the company. Right. So that release calls we have to join as a developer so that we will understand how our project is delivering to the client, how our project is deploying in the real environment, and how the project is mapping to the domain. Domain mapping is one-time activity in the project, but a production deployment for every 2 months, for every 3 months, production deployment will be there. We have deployed the project in the month of April. Now in the June, we have the deployment, production deployment. Project already running. We got some enhancement in the projects. From 2 months, we are working on the enhancements. Those are completed. Development completed. Testing is completed. Non-prod testing is completed. We tested in the dev. We tested in the SIT, in the UAT, and in the pilot. Everything is done. It is ready to go for live. So that live will happen this Friday. This Friday at 5 o'clock, release call meeting will be available. Everybody will join in the meeting. DevOps team will do the deployment. So that is the process in the real time. Read it again. Real time deployment process. Dev team will create JIRA ticket for Jenkins pipeline creation. Dev team member will take the ticket and will assign to his name. Once ticket is assigned, I am responsible to follow up the pipeline creation. Send the request to DevOps team to create pipeline for non-prod with Git repo. In my project, this step is not available because who is going to take the ticket? That person should create the pipeline. DevOps team will create pipeline and will give the reply to our email as confirmation. Pipeline created, please validate. So what is the meaning of validating the pipeline? Whatever the project we have, for which project that pipeline is created, deploy that project using that pipeline. Is it working or not? If it is working, good, then close the ticket. If it is not working, see why it is not working. Is it code problem? Is it pipeline problem? Code problem means we have to fix. Pipeline problem means DevOps team will fix it. Every team member will have Jenkins access. User account will be created. Non-prod environments, dev team will handle. Prod environment, DevOps team will handle. In some companies, everything will be handled by DevOps team. In some companies, this process. My previous company in the Deloitte, everything will be handled by DevOps team. So as a developer, when I am working in the Deloitte, after committing the code to the GitHub, we don't know how the code is getting deployed. But in my present company, we are responsible. We got the complete clarity on the DevOps practices, how to work as a DevOps engineer. What are the roles and responsibilities of the DevOps engineer? We are working on that, right? Mostly in the service-based companies, DevOps team will take care of this process. In the product-based company, developers will take care of some DevOps operations also. Very good. Fine. So with this, we completed our discussion on Jenkins. I will make one video, Jenkins plus Docker integration, how to do the final deployment process. Good. Fine, guys. So we completed our discussion related to Docker and we learned Docker Compose. We understood what is Docker. We understood what is Docker Compose and we learned what is Kubernetes and we discussed about Jenkins CI/CD. What is the purpose of Docker? What is the purpose of Docker? Docker is used to containerize our application. So instead of installing all the softwares in the machine to run the application, we are going to package our application plus application dependencies as a Docker image. Using that Docker image, we can run our applications easily. Next one, Docker Compose. Why we need to go for Docker Compose? If you want to create multiple containers at a time, if you want to manage multi-container based applications, then we need to go for Docker Compose. And the next one, Kubernetes. What is the purpose of Kubernetes? Kubernetes is an orchestration platform. So managing the containers will be taken care by Kubernetes. So the main advantage with the Kubernetes, self-healing, load balancing, auto scaling, high availability will be there for the application when we go for Kubernetes. So along with this Kubernetes, we understood EFK. We understood EFK stack. What is the meaning of EFK stack? Elasticsearch, Fluentd, and Kibana. Why we need to go for EFK stack? To monitor our logs at centralized location. So multiple applications will be running in the Kubernetes cluster. Multiple pods will be running, multiple microservices. I have 7 to 8 microservices. The 7 to 8 microservices will run on Kubernetes cluster. So several logs will be generated. So every application will generate the logs. Monitoring the logs of all the microservices separately is very difficult. So that's why we will go for centralized logging. To go for centralized logging, we are going to use EFK stack, Elasticsearch, Fluentd, and Kibana. Elasticsearch is used to store the logs. Fluentd collect the logs and store in the Elasticsearch. Kibana is a web application which is used to get the logs from the Elasticsearch. Now, next one, build and deployment process. We can do the build and deployment process manually. We can do build and deployment process manually, but lot of time is required and there is a chance of doing human mistakes. So in order to do the build and deployment, every day we need to do the build and deployment several times in the several environments. Dev, SIT, UAT, pilot, prod, several environments will be available. So if I want to do that build and deployment manually in the several environments, lot of time is required. And second one, there is a chance of doing the mistake. So that's why we are going to automate our build and deployment process. To automate build and deployment process, we are going to use Jenkins. So Jenkins is a CI/CD software. It is open source software. It is developed using Java. So we need to install Java first, then we can go with the Jenkins, right? Now, in the Jenkins, we can create the jobs in two ways. One is by using freestyle project and the second one is by using pipeline, right? So if you see, the recently I have created one project, Java web app deployment. So this deployment we have done by using freestyle project. So I have taken a Jenkins machine. I have taken Tomcat server. So Jenkins will take the code from the GitHub. So the architecture that we implemented, our code is available in GitHub. Here, the code is available in GitHub. This is our GitHub repository where our project is available. Now, this is a machine. This is one Linux machine in which our Tomcat server is running. This is a machine in which our Tomcat server is running. I need to take the code from the GitHub and I need to compile that code. I need to package that code. I need to deploy that code into Tomcat server. So in order to do that, I have used one software called Jenkins software. So I have taken another Linux machine. In that machine, I have installed Jenkins. Then in the Jenkins machine, I installed one software that is Maven, right? Why Maven? To compile and package our application. So in the Jenkins, I created a job. What that job has done, it has taken the code from the GitHub, then it has given that code to the Maven goal. Maven compiled and packaged, then Jenkins deployed that code into Tomcat server. So here, step one, take the code, build that code, deploy that code. take the code, build that code, and deploy that code. If you just run the Jenkins job, it will do the build and deployment process. So that build and deployment process we have done by using freestyle project creation, because it is simple. Build and deployment, just take the code, compile the code, and deploy that code into Tomcat server. So that we created by using freestyle project. If you have complex process, then you can go for CI/CD pipeline. So CI/CD pipeline, nothing but set of stages will be available. Stage 1, take the code. Stage 2, do the build. Stage 3, create the image. Stage 4, create the container. If you see another video, DevOps project setup is available. 1.5 hours I explained how to create Jenkins CI/CD pipeline. So this video is from my DevOps batch. This video is from my DevOps batch. In this video, I created a pipeline. In this video, I created a pipeline. That pipeline will take the code from GitHub. We'll do the build by using Maven. We'll do the review by using Sonar. We'll upload the WAR file into Nexus repository. And finally, we'll deploy the code into Tomcat server. Multiple stages are available in this Jenkins pipeline. So if you see the pipeline process here, this is our Jenkins pipeline. Right. Apply now, build now. You see, clone the repository, do the Maven build, do the code review, upload, build artifact into Nexus repository. But finally, this pipeline has done 5 stages. Clone the repository, do the Maven build, perform the code review, upload artifact into Nexus, and deploy the application to Tomcat server. This is CI/CD pipeline. Good. Instead of this Tomcat, we will use the Docker. That's it. Stage 5 will be different. Here it is a normal web application. That's why I deployed into external Tomcat server. For Spring Boot application, external Tomcat is not required. We will run that by using Docker container. So instead of the Tomcat server, we will use a Docker for that. Stage 6 will be Kubernetes. That's it. Stage 7, sending the email. Good. Log monitoring also, I have explained how to set up EFK in the Kubernetes cluster for the logs monitoring. In the class also we have done how to do the log monitoring for our application. Perfect. So with this, we are good. Guys, these are tools that what we discussed from last 1 week, 10 days, these are hot cake in the market. And these are called as DevOps tools. Docker, Kubernetes, EFK, and Jenkins. Along with this, people will call Git, Maven, Tomcat also DevOps tools. So in the DevOps as well, for the DevOps people also we will teach Git, Maven, and Gradle, that Docker, Tomcat, Kubernetes, EFK, Jenkins, CI/CD. All these tools we are going to teach in the DevOps. So in the DevOps course, in the DevOps, the extra tools that we are going to teach is Ansible, Terraform. That's it. If you know Ansible and Terraform, that means you know DevOps also. So what is this Ansible? It is used for configuration management. So that means installing the software in the multiple computers at a time. For that, we are going to use playbook, YML files we are going to write. Terraform. What is the purpose of Terraform? It is used to automate infrastructure creation. Now, we learned AWS. Why we used AWS? Infrastructure creation. What infrastructure we created in the AWS? We created EC2 machines. We created load balancers. We created RDS. We created IAM user, right? Whatever we created in the AWS through web console, right? We logged into AWS account and we created EC2 machines. We created RDS database. We created IAM users in the AWS cloud. Instead of we are creating that manually, we can automate EC2 creation, database creation by using Terraform. Terraform is used to to create infrastructure, VMs, DBs, IAM users, etc. Whatever we created manually, that for beginners, we will do the infra creation manually when you are learning AWS. But in the real time, manual process will not be available. Why manual process will not be available? Human errors, lot of time, human errors. We may do some mistake. So that's why we are going to write some code to create the infrastructure. That is called infrastructure as a code. I want to create one MySQL database in the AWS. I will write one code. I will execute the code. If I execute the code, it will create infrastructure in the AWS. It will create a database in the AWS. I want to create one EC2 instance. What is EC2 instance? One virtual machine. So we are creating EC2 instance manually. Instead of we are creating that manually, we will write the code. That code will create the EC2 instance in the cloud. We are creating S3 bucket manually. We will write the code to create the S3 bucket. That is called Terraform. Right. Now, if you are having some time to learn what is Terraform, I conducted one workshop on the Terraform. So that is 2 hours workshop. If you see this Terraform workshop, Terraform tutorial for complete beginners. So 1 year back, I have taken one. This is my DevOps class only. I explained it Terraform. So we installed Terraform, and this is the script which is used to create EC2 instance. This is the code that we are going to write to create Terraform script. If I execute that code, it will create EC2 machine in the AWS cloud. Similarly, if you see the code to create a database, S3 bucket we are creating. Similarly, we can create a database also. Yes. Now, this is the code that is used to create RDS in the AWS cloud. We create a database manually in the AWS cloud. Instead of doing that manually, we are going to automate that. To automate that, we are going to use Terraform. Good. So it's very simple for the developers. If you spend 2 hours, you can become master in the Terraform. There is nothing. Just you need to write some script. This script is not Java, not Python, not JavaScript. This is HCL. HCL nothing but HashiCorp configuration language. They have their own syntax. By using that syntax, you need to write the code. Using that code, you can create infrastructure in the cloud. Similarly, we are having another software that is called Ansible. Ansible is for configuration management. I want to copy the files from one machine to another machine. I want to install Java in 100 machines. Instead of installing Java manually, we can go for Ansible to install the Java in 100 computers at a time. So for that, we are going to use playbooks. Playbook is a YML. What is playbook? Playbook is a YML. We already know what is YML in the Spring Boot. Similarly, in the Ansible, we will write the playbook. Using that YML, we will install the required softwares in all the computers at a time. At a time, I want to install Java in 1000 computers. If I install Java manually in 1000 computers, how much time? 1 month it will take. By using Ansible, in 1 second, we can do that. So that is configuration management. If you know these 2 tools, then you are DevOps engineer as well. You are Java plus DevOps. So in the DevOps, what tools we need to learn? Git we need to learn. Do you know Git? Yes. And you need to know first Maven. You need to know Maven. Why we are using Maven? As a build tool. Maven we are using as a build tool. GitHub we are using for repository. And third one, we need to know Tomcat. What is the purpose of Tomcat? To deploy normal Java web application as a WAR file. And we need to know SonarQube. What is SonarQube? SonarQube is used for code review. SonarQube is used for code review. And the next one, Nexus. In the Maven classes, we use Nexus for remote repository. What is remote repository? Shared libraries will be available. For multiple projects, some common libraries will be available. To work with the common libraries, we are going to use Nexus. We use Nexus as well. Then after this, we are going to use Docker. What is the purpose of Docker? It is used to simplify the deployment process. It is used to simplify the deployment process of our application by using containerization. Next one, Kubernetes, used for orchestration purpose. Next one, EFK. So EFK, it is used to monitor logs of our application. Then we need to know Ansible. First, we need to know Terraform. Terraform is used to automate infrastructure creation. Then we are going to use Ansible. It is used to manage configurations. So in my DevOps course, I'm going to teach these tools. If you see our DevOps course content in the website, you can understand. Go to DevOps with AWS. See the course content for that. We are going to learn what is DevOps. What is DevOps? Development plus operations. What is SDLC? What is waterfall model? What is agile model? DevOps life cycle. What is DevOps? What is build? What is deployment? What is source control? Environment, integration, testing, deployment. Then we are going to learn Linux. What is Linux? How to work with Linux? Linux flavors, Linux architecture, commands, files, user management, groups, file system, VI editor, shell scripting will be available. Then Git will be available, Git branches, Git commands, Maven, then Jenkins, okay. Then Sonatype Nexus repository, okay. Ansible will be available, Docker, containerization, Kubernetes, orchestration, okay. ELK stack or EFK stack, monitoring tools will be available. Infrastructure as a code, Terraform will be available. With this, DevOps is completed. So we missed just two tools, Terraform and Ansible. Coming to AWS. AWS Cloud. What is cloud computing? Why we need to go for cloud computing? How to create virtual machine in the AWS? What is EC2? What is region? What is AMI? What is EC2 instance? What is Blackstore, EBS, load balancer, VPC network? VPC will be available, auto scaling. Then S3 buckets will be available. Route 53 will be available. RDS database will be available. IAM will be available. CloudWatch, some notification services will be available. So with this, AWS will be completed. That means 80% of DevOps and AWS, as a developer, we should know. As a developer, we should know. Here, Kubernetes we discussed in 2 to 3 days. But in the DevOps, they should work on the Kubernetes. We will explain Kubernetes for 2 weeks. We will go at administration level. For the developer, we have the basic idea. For the DevOps engineer, we should learn at the administration level. In the Git, we have seen all the Git commands, Git bash and all that stuff. Tomcat server, SonarQube, Nexus, Docker. We discussed about the Docker commands, Docker images, Docker containers and all. When we go for the DevOps, Docker network, Docker volumes, Docker logs checking, debugging, administration level, how to compress the Docker images, right? So at that level, we are going to learn that, right? For the developers, that administration knowledge is not required at this time. If I teach at that administration level, you will deviate from Java to DevOps. You will miss the coding. You will forget about the coding. You will concentrate on the administration. We are not here for the DevOps. We are here for the Java. So as a Java developer, you should know operations also. Nowadays in the industry, industry is expecting every developer should know DevOps tools also. Operations tools are important. To be frank, till I get 6 to 7 years of experience, I don't know about several tools here. But in my previous company, I did not get that opportunity because their separate DevOps team, we are responsible to write the code and commit the code to GitHub. Then forget about it. Everything will be taken care by operations team. In this current company, we got very good opportunity to do the operations as well. Now I can say I am Java developer with DevOps experience because I am doing the DevOps operations in the company, and we learn AWS cloud, we learn Linux. So to become DevOps engineer, Linux plus scripting, some shell scripting is required, plus AWS cloud is required, DevOps tools are required. Then completely you will go to administration side. Good. Perfect, guys. So as a Java developer, we need to learn how to develop our applications by using Spring Boot with microservices, and how to deploy those applications in the cloud platforms by using operations. Now, when you are preparing your resume, you need to keep these things in your skills. Java, J2EE, then we need to keep Linux. Basically we need to keep Spring Boot, we need to keep microservices, and we need to keep Kafka, Apache Kafka. That is very, very important now. Next one, we need to keep as Redis cache. Redis cache we discussed. What is Redis cache? And we need to keep security, that is Spring security that we learned. And we need to keep Linux commands. We know what is Linux, how to work with Linux commands. And we need to keep AWS cloud. We know what is virtual machine, what is cloud database, what is IAM user in the cloud, how to create S3 buckets in the cloud, how to upload the objects in the S3 cloud. And we need to keep DevOps tools. In the DevOps tools, mainly we are going to keep Docker, Kubernetes, EFK, Jenkins, Git, Maven, Sonar. These are the tools that we are going to keep. Docker, Kubernetes, EFK, Jenkins, Git, Maven, Sonar. Git, every developer should know Git to commit the code, to take the code. Build tool, Maven. Sonar for the review. Jenkins for CI/CD. EFK for log monitoring of our application. Kubernetes for orchestration. Docker for containerization. And we know Jira, task management, agile methodology with the Jira tool, how to create the stories in the backlog, how to do the sprint planning, how to assign the story to our name, how to change the story status. That project management tool also we know. So we learn just Java, or we learn DevOps also? Java with DevOps we learned. Good. So if you know these things, you are eligible to attend experience interviews. In the experience interview, mainly they are going to ask you how code deployment will happen, how you will troubleshoot the issues, how project deployment will happen, how many environments will be available, how you will get the task, how you will complete your task on time. If you are not able to complete the task on time, then how you will give information to your Scrum Master, who will assign the task for you, how you will monitor logs of the application, what is the deployment strategy of your application, who will create the Git repositories for your project, who will create Jenkins pipelines for your project, who will set up Kubernetes cluster, who will set up log monitoring by using EFKs, who will do the EFK setup. Have you ever worked with Linux machines? Did you ever monitor logs available in the Linux server? Did you create a database in the cloud? Do you know how to implement storage for the project? How to manage unlimited storage? How to use message broker in the application? How to secure your application? What is Spring security? What is OAuth? What is JWT? What is basic authentication? What is config server? What is config server? What is microservices? How many microservices are available? What is inter-service communication? How you will perform distributed tracing of your microservices? What is the Zipkin? What is the purpose of service registry? What is config server? What is inter-service communication? How you will access third-party APIs in your API, in your microservice? So these kind of questions will be asking in the experienced interviews, right? Along with these things, logical programming is required. Logical programming, on the arrays, strings, Java 8 collections. Mainly they are going to ask on the logical programming. Good. Huh. Okay, we'll see that. And next one, you guys are learning Angular. Okay, so front end. Along with the back end technology, you need to know one front end technology as well, right? Java, J2EE. Here we need to implement logical programming, logical thinking, logical program, that is problem solving. Basically, we need to know problem solving. If you know all these things, then you are called, along with these things, problem solving, along with these things, we are going to use one database, right? You guys attended Oracle, either Oracle or MySQL. At least you should know some SQL concepts, right? SQL concepts are required. This is our skill set. I think we spent enough time, almost 8 to 9 months of time we have taken, 10 months. Whatever I know, whatever I learnt in the 10 years of time, we discussed in the 10 months, right? Java, J2EE. Java nothing but mainly core Java. So here we had learnt about OOPS concepts, right? And collections framework, multi-threading, exception handling. Coming to J2EE, here servlets, mainly advanced Java. We can say it is advanced Java. Here we learned JDBC, servlets, JSP, that is not that much required, guys. We did not concentrate much on the JSP. Problem solving, that is logical programming classes are going on. Database, SQL already completed for us. Spring Core and Spring Boot, right? So JPA, data JPA, Spring Core module, JPA, MVC, REST API development, then microservices, Kafka, Redis cache, config server. We learned about cloud config server, right? Cloud config server is also very, very important, guys. Cloud config server to externalize configurations of our application. We will not keep configurations within the project, because if you keep the configuration within the project, what is the problem? Yes, every time we need to recompile the project, we need to repackage our application, we need to recreate the Docker image. So a lot of maintenance will be available. So to avoid that maintenance problems, we are going to use cloud config server. Application will be separate, configuration properties will be separate. Good. Kafka, message broker. So if you want to exchange the messages from one application to another application, Apache Kafka we are going to use. Redis cache, Spring security. And along with this, we used unit testing with mocking, JUnit with mocking, right? How to perform unit testing of our application by using JUnit, and how to implement isolated unit testing. What is the meaning of isolated unit testing? Individual components we have to test. One component may have dependency with the another component. To avoid that dependency, we are going to use mock objects. We'll create the mock objects and we are going to perform unit testing with the mock objects. Then Angular. Angular is a front-end framework to develop user interface. So if you know Spring MVC, then Angular is very easy. Angular component is equal to Spring controller. Angular service is equal to our business service classes. Angular template is equal to our view file. Data binding will be available. Modules will be available. Directives will be available. Pipes will be available. Then we discussed about Linux. Linux knowledge is very, very important in the real time, especially for the experienced developers, because we need to work with the Linux machines for the deployment, for logs monitoring and all that stuff. AWS cloud. So cloud infrastructure. Instead of managing our own infrastructure, instead of purchasing our own infrastructure and managing our infrastructure, we are going for cloud infrastructure. Cloud machines, cloud database, cloud storage, everything will be there in the cloud, right? We will just pay the monthly bill cloud provider will take care of the infrastructure required for the project. And coming to operations. So only if you write the code, project will not be completed. Along with the coding, we need to use some tools also to test, to deploy, to deliver our application. To simplify the deployment process, we are using Docker, containerization. To manage the containers, we are using Kubernetes. To centralize log monitoring of our application, Elasticsearch and Kibana. To automate build and deployment process, Jenkins. To manage the source code of our project, Git. To build our project, Maven. To review the code, Sonar. To do the project management, Jira. Jira is a management tool. That means which developer should work on which task, which team member should work on which task, how many stories are completed, how many stories are pending, and bugs. What are the bugs are identified by the testers. Bug reporting also will happen in the Jira tool. So every software engineer will use Jira tool in the company on daily basis. Good. So this is what we learned so far. Along with this, we implemented 3 mini projects also. How to perform CRUD operations, how to generate reports in our application, how to develop a portal to manage inquiries in any office. It may be an institute, it may be a school, it may be a college, it may be a gym. So daily inquiries will come. How to manage our daily inquiries by using employee portal, and how to develop one blog application, how to post blog, how to read the blogs, how to comment the blog, how to display the comments. One blog application also we have developed. And we discussed one major project architecture, how a project will be there in the real time, how many modules in the project, what is the purpose of the module, how that project is helping the people in the real world, right? So government want to provide some health and insurance plans for the citizens. So providing health and insurance plans manually is very difficult. So that's why they want a system to manage health and insurance plans. For that, we are developing one IES application, that is integrated eligibility system. In that, administration module available, caseworker module, application registration module, data collection module, eligibility determination, correspondence module, reports module, benefit issuance modules are available. Good. So some people done the major project implementation, some people has not done that. So I want you people to do that so that you will learn. Once you develop all the REST APIs for the major project, for every project we need to create one Docker file which is used to Dockerize our application. And for every project we need to create one Jenkins pipeline so that we can run our project by using that Jenkins pipeline, so that it will be deployed as a Docker container. So once all these things are available, UI project we will create. UI project also we will Dockerize. Angular projects we are creating. That Angular project, one Angular project will be available. In the backend, multiple REST APIs will be available. This Angular project will use HTTP client module to access the backend REST APIs. That Angular project URL we will map to the domain name, that is DNS mapping by using Route 53. When you access the domain, Angular application will open. When you perform operation in the Angular application, it will access backend REST API. So that is the complete project setup. Good. So if anybody has not done the project, please try to do it. So in the tomorrow's class, we are going to learn performance testing by using JMeter. So what is the JMeter? What is the performance testing process? Why we need to go for performance testing? How people will do that performance testing in the company? We will learn that in the tomorrow's class. Okay, good. Thank you guys. With this, I'm stopping for today. We'll continue in the tomorrow session.